Hi guys, greetings of the day. I Vijaytavardhan welcome you to my YouTube channel for learning a subject called as Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per YouTube syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on the bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 10. The session number 10 is going to be with respect to the positive displacement pump we are going to discuss. Now, what is called as positive displacement pump? Let us have a figure over here. And the most pumps used in the oil hydraulic power systems are positive displacement pump. It is called positive displacement pump because the liquid will always be in contact during its cycle of operation with the moving pumping elements such as piston, valve, gear, etc. inside the casing of the pump. In a positive displacement pump, the pumping element moves from a small volume to a large volume and then from large volume to a small volume during each pumping cycle, which is as shown in the figure, which is self-explanatory. Now, this type of pumps gives a fixed volume of oil, that is a liquid, per pumping cycle into the hydraulic system, and these are capable of overcoming the resistance due to external load as well as the resistance to flow due to friction. Since the fixed volume of oil is discharged per pumping cycle, the displacement characteristics of the pumping chamber and the volume of pump for a given pump is dependent on the number of pumping cycles made by the pump or a pumping element per unit time. Then what is called as a pumping cycle? The pumping cycle may be defined as the movement of pumping element from small volume to the large volume and then from large volume to the small volume, which I have explained just now. Now, in such pumps, the fluid enters and leaves the pump at the same velocity, that is, there will not be any change in the kinetic energy during the pumping cycle. As these pumps provide the pressure with the common of oil acts against the load and hence the hydrostatic pumps. Then coming to the one more topic in this, that is called as pumping theory. What is called as pumping theory? As the piston moves from left to right, you can see in the figure, the air in the cylinder expands, resulting in decrease in oil pressure of the air below the atmospheric pressure, and the space to the left side of the piston experiences suction or a partial vacuum. Due to this, the liquid enter the cylinder and come in contact with the surface of the piston, and as the piston moves further left, more liquid is drawn or sucked into the cylinder. And this continues till the piston reaches the dead end. The inlet of the liquid to the cylinder is through the inlet port, that is called a suction valve, which is the one-way valve that opens inside during the suction of the liquid. As the piston moves towards the left side of the suction valve, closes the oil inside the cylinder and also in contact with the piston gets squeezed. That is, the pressure is increased and continues to increase till the outlet valve opens and allows the pressure oil to leave the cylinder. And make a note that the opening and closing of the valves, which are the one way and is completely controlled by the spring provided in the valves. This is about the pumping theory. And what are the advantages of the positive displacement pumps? The advantages of the positive displacement pumps are as follows. One is it is capable of generating high pressure up to 70 megapascals or even higher, and the small and compact, and it enjoys a very high power to weight ratio, high volumetric efficiency, and very small variation in efficiency throughout the design pressure range, and greater flexibility of the performance over varying speed and the pressure ranges. Then coming to one more topic in this session, that is called as terminologies associated with the positive displacement pump. we'll follow the terminology one by one. The first one is called as volumetric displacement. It is normally given by V suffix T, but here it is given as Vd, but it is supposed to be V suffix D. Okay, it's a small mistake. You can please correct it. Now, what is this volumetric displacement? Volumetric displacement or theoretical displacement of a positive displacement is the volume of the liquid pumped in one revolution. It is equal to the volume of one pumping chamber multiplied by number of chambers that pass the outlet in one revolution. And the volumetric displacement is expressed in cubic meters per revolution or meter cube per revolution. In this case, the single cylinder pump, the number of chamber is 1, then the Vd will be equal to meter cube per revolution. Then coming to another type of terminology that is called as flow capacity or discharge, which is also called as theoretical flow rate. The flow capacity or discharge of a pump is the volume of oil discharged per unit time denoted by Q and expressed in meter cube per minute. Then coming to one more terminology that is called as volumetric efficiency. Volumetric efficiency of a pump is the ratio of actual discharge to the theoretical discharge and is usually expressed in percentage. Then we have pump rating. A pump is generally rated by its maximum pressure P and the output flow, that is Q actual at a given drive speed. What is Q actual? Q actual is nothing but the actual pump discharge, and QTH will be called as theoretical pump discharge. Then coming to hydraulic torque, the hydraulic power of a hydraulic system is the product of pressure of the fluid in newtons per meter square and a discharge in cubic meter per second. And the unit will be usually Pascal. Then coming to the hydraulic power, that is what we have discussed, sorry, hydraulic torque. And then coming to pumping cycle. What is called as pumping cycle? The movement of the pumping element from small volume to a large volume and back to a small volume constitutes a pumping cycle, which you can see in this figure very carefully. The small volume to a large volume and large volume to a small volume with respect to reciprocating compressors, that is piston cylinder arrangement, and if it is gearing arrangement, either it could be a vane pump or a gear pump, or it could be external or internal, whatever it may be, it is explained by this. Now, based on this, I would like to conclude my session number 10. Thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in the session. And don't forget to like, share, and subscribe. Have a great day. Signing off, Vijay Tavardhan.